Hi, welcome to Code with Z. In today's video, we gotta go from this number that we have here that we're calling n to this matrix. Why? Well, because that's what LeetCode 59 Spiral Matrix 2 is asking us to do. As you can see, we're given a positive integer called n, and we gotta generate an n by n matrix filled with elements from 1 to n squared in spiral order. Now, what does spiral order even mean? Well, let's check that. So from n, we gotta generate a matrix like so, and then we gotta fill it with numbers in spiral order. Spiral order is basically this. So we're gonna have 1, 2, 3, and then we're gonna say 4, 5, 6, then 7, 8, 9. So we saw this kind of a movement. We went from first row, first column, first row, first column, all the way to first row, last column. And then we went from first row, last column, all the way to last row, last column, like so. And then we went from last row, last column, all the way to last row, first column. And then we went from last row, first column, all the way to first row, first column, like so. But each time when we make these movements, we're not gonna go through cells that we've already been at. That's why when we actually get to 3, we're not gonna go over 3 again. We actually start from 4 to 5. So you actually need to know which cells we've been already at. We're gonna have the same motion, but we only have to be careful that we do not go over the same cell twice. Now that we have finished our 4 movements, we have to repeat it because we still have cells that we've not been at. So we're gonna repeat what we had. We said we're gonna go from the left to right. So this was our first movement, and we went from first row, first column, to first row, last column, right? But because we've already covered this time we're gonna start from this position, and we're gonna go from left to right, and this is only gonna go across this cell that we have here. And this is how we fill this matrix with our numbers, like so. So we basically have 4 movements. So let's see how we can actually create these 4 movements with code. Let's first bring this down. In our 4 movements, we can define 4 variables to easily recreate this movement that we have here. So let's do that. We're gonna call the first one top, and as the name suggests, it's gonna be representing the top of our matrix, and we're gonna have a variable called right. And again, as the name suggests, it's gonna be representing the right side. Then we're gonna have bottom and left, like so. And we're gonna use these 4 to recreate our movements that we saw in the previous slides, like so. And on each time, when we actually go through the top of our matrix, we're gonna update our top variable so we do not go across the same position. So these 4 variables are gonna be basically helping us to define our boundaries and to let us know if we've been at a place before or not. So each time when we actually visit a row or a column, we're gonna update our variables so we know that we should not go across that row or column again. And that's why when we set these boundaries, we're gonna have a movement like this. As you can see here, we're not gonna cross one cell twice. We've only been to each cell once. These boundaries that we define here are gonna help us to actually create this. It's basically this movement, but these 4 variables are gonna help us to go from this movement to this. Now, let's code this in the simplest way possible. Alrighty, so the first thing that we need to do is to make our matrix. In the slides, we had a matrix that was empty, but here we're gonna have a matrix that's filled with zeros. So we're gonna say matrix is equal to an empty array. Then we gotta turn this empty array that we have here into this. This is the empty array that we currently have, and we gotta fill it with n rows. As you can see, if n is 3, we have n rows and n columns. So if n is 3, we're gonna have 3 columns. So for doing this, we're gonna define a for loop. We're gonna say for let I being equal to 1, and we wanna keep on looping as long as I is smaller or equal to n, and n was given to us here, and we wanna increment I on each round. So this is gonna be a basic for loop. Here we're gonna say matrix dot push. So we're pushing something inside of our matrix. We're gonna push a new array with the length of n. Why are we doing this? Because let me bring our matrix back. This is our array, right? So this is this. We gotta fill it with n arrays. As you can see, 3 arrays if our n is 3. So we're saying we wanna keep on looping as long as our I is smaller or equal to n. That means if our n is 3, we're gonna do this 3 times. So we're gonna add 3 arrays because each time in our loop, we're gonna push a new array with the length of n because our matrix is 3 by 3, and we're gonna fill this array with zeros, and we're gonna push it into our matrix like so. So all you need to know, these lines are gonna make our array dynamically. So even if our n is 4, it's gonna make 4 rows and 4 columns, and it's gonna fill them with zeros. Then here we're gonna define our 4 variables that we saw in the previous slides. So top is gonna be equal to 0, because if we check, top is literally at the first row of our matrix, and the index of the first row is 0. And left is equal to 0 as well, because left is pointing to the first column inside of our matrix, and the index of the first column is also 0. Then we're gonna have bottom, and this is gonna be equal to n minus 1. Why? Because bottom is pointing to the last row inside of our matrix, and the index of the last row inside of our matrix is gonna be whatever n is minus 1. For example, if n is 3, the index of the last row is gonna be 2. So 3 minus 1, that's gonna give us 2. And same thing for right. Right is gonna be equal to the last column inside of our matrix, and this is gonna be also equal to n minus 1. Now we're gonna define one more simple variable, and that's gonna be size, because we're gonna check the size of our matrix a lot. So we're just gonna call it size, and we're gonna say this is equal to n by n. So if our n is 3, our size is gonna be 9, because 3 multiplied by 3 is gonna be equal to 9, and that size represents the amount of cells that we have inside of our matrix. If we check the picture here, we can see that we have 9 cells. So this is basically just telling us how many cells we have. We're gonna add numbers to this matrix until 9, because the size is 9. And if we start from 1, and if we fill each cell with a number, the maximum number that we can have is gonna be 9, because that's gonna be the size of our matrix. So we're gonna also have a variable called num, and this is gonna start from number 1. This is gonna be basically the numbers that we add to our matrix. So in the beginning, we're gonna add 1, then 2, then 3. So this means each time we add number to our matrix, we have to increment it, so we don't add, for example, 2 1s in 2 different cells. Then below this, we're gonna define a loop. We're gonna say we wanna keep on looping as long as number is smaller or equal to the size. And this makes a lot of sense, because when our number reaches the size of our matrix, that means we're done. As you can see, here, when we reached 9, there were no more cells to actually fill them with numbers. So we're gonna say we wanna keep on looping as long as number is smaller or equal to size. Here we have to recreate the movements that we had. So in the beginning, we went from the first row, first column, all the way to first row, last column. So we basically went from the left to right. So we're gonna say for let I being equal to left, and we wanna keep on looping as long as I is smaller or equal to right, and we wanna increment I on each round. Here, we're literally going to go from the left to right. And then we have to get our matrix like so, and we got to give it 2 values. The first one is going to be the row, and the second one is going to be the column. So we got to tell it which column, which rows we want. Well, we know that we want the first row, and that's going to stay consistent, but our columns are going to change. So we want the first row, first column, then the first row, second column, then the first row, third column. So the rows that we have are gonna stay consistent in this movement, right? And if we check, our top variable is equal to the index of this row. This is the first row, and this row has the index of 0. So we're gonna say our row should be top, basically the first row, but our columns should change. And this is gonna be I, because I is gonna change throughout this loop, and it's gonna be a dynamic value. And each time we're gonna say this position should be equal to num, and then we're gonna increment num on each round. After we're done, we gotta make sure we're not gonna go through the same cells, so we're gonna update our top value, because we just covered this row that we had, so we don't wanna go through it again. Then the next movement that we had was that we went from here to here. So this time we're gonna go from the first row, last column, all the way to last row, last column. And if we check, we literally go from the top to the bottom. So we're gonna say for let I being equal to top, and then we want to keep on looping as long as I is smaller or equal to bottom, and we want to increment I on each round. Here we're gonna have our matrix and its 2 values. We gotta give it the correct values for our rows and our columns. Well, if we check, our row is gonna change. We're gonna go from the first row, last column, to the second row, last column, then to the third row, last column. But our column is gonna stay consistent, and our right variable is basically equal to the index of the last column. This is literally the rightmost column, and our right variable is equal to the index of that column. So we're gonna say column should be right, and it should stay consistent because we only go through one column, but our rows should be dynamic, so this should be I, because we change our rows on each iteration of our loop, and then this should be equal to num, and we're gonna update num each time, and we want to make sure that we don't come across the same column again. So we're going to update our right variable like so. The reason we decrement it is because we go from the right to left. This column has a greater index than this one, and we want to make right point to this column now. So we decrement right. Then the next movement that we had was that we went from here to here. We went from the last row, last column, all the way to last row, first column. And this is basically going from right to left. So we're gonna say for I being equal to right, like so, and we wanna keep on looping as long as I is greater or equal to left, and we wanna decrement I on each round. The reason we have a reverse loop is because right is greater than left, and because we want to say go from right to left, we gotta have a reverse loop. Here we're gonna have our matrix, and it's two values again. This time the row stays consistent, but our columns change, and our row is basically the bottom row. If we check here, our bottom variable is equal to the index of the last row. So we're gonna say the row should have the value of bottom, but our columns should be dynamic and they should change. So that's gonna be I, and this is gonna be equal to num, and we're gonna increment num on each round, like so. After we're done, we gotta make sure that we don't come back to this row again, so we gotta update our bottom variable, like so. The reason we decrement it is because this row has a larger index than this one, and now we gotta say bottom variable should be equal to the index of this row, and because this row has a smaller index than this one, we're gonna decrement the bottom. Then our last movement was that we went from here to here. We went from last row, first column, all the way to first row, first column. But because we've been through this one here, we're not gonna actually get to the one, and we're gonna stop here. But we don't need to worry about that because we've updated our for variables accordingly already. So we're gonna say for let, and if we check, we're gonna go from bottom to top. So we're gonna say for let I being equal to bottom, and we wanna keep on looping as long as I is greater or equal to top, and we wanna decrement I on each round. We're gonna have a reverse loop because we're gonna go from the bottom to top, and the row at the bottom has a greater index than the row at the top. So we're gonna say matrix with its two values. Our column is gonna stay consistent, but we're gonna change rows. So we're gonna put I in the row position, and if we check, our left variable here is equal to 0, and this is equal to the index of the first column. So we're gonna say left, like so, and this should be equal to num, and we want to increment num, and then after we're done, we don't want to come back to this column again, so we're gonna update left, like so. Now this is gonna be it. At the end, we're gonna return our matrix, but each time we have these for loops, we gotta make sure they only run as long as this condition is also true. So we're gonna copy this, and we're gonna add this here. I didn't want to make the for loops crowded in the beginning, but we're gonna have the same thing. We're just checking if this is also true or not. So like this, and we're just gonna add it once more, and this is gonna be all of our code. Let me zoom out so you can actually see it. Let's run it. I hope I've not made any typos. Moment of truth, and yep, we got accepted. That's awesome. That means I've not made any typos. Let's see if we're gonna get accepted. And yep, that's awesome. Thanks for watching. Don't forget to like and subscribe, and keep on coding.